An elephant stands over the bones of another elephant, not a fresh carcass, not an animal that died recently, just bones, scattered and weathered, that could have been lying there for years. The elephant approaches slowly, reaches out with its trunk, and begins touching the bones, running the tip of the trunk over the skull, the tusks, the jaw. It stands there for minutes. Other elephants in the group approach and do the same. They don't do this with the bones of other species. They don't do this with rocks or fallen trees, only with elephant bones. Nobody taught them to do this, nobody rewarded the behavior. It appears in elephant populations that have never witnessed another elephant doing it, and it has been documented so consistently across so many separate field observations on multiple continents over several decades that it is now one of the most well-established examples of what researchers cautiously call death-related behavior in non-human animals. What it means, whether the elephants are grieving, whether they understand what those bones represent, whether they have some concept of death that drives the behavior, is one of the most fascinating and most contested questions in all of animal behavior research. And it is one of a growing body of questions that, taken together, are forcing a significant revision in how scientists think about animal cognition, animal emotion, and the evolutionary origins of one of the most fundamental human experiences. Let's go through it properly. Start with the question itself, because it is deceptively complex, and the complexity is where all the interesting science lives. Do animals know when someone dies? The question sounds simple. The answer requires you to unpack what the word know means in this context, what the word someone means across species, and what the concept of death actually requires in cognitive terms to be understood rather than simply responded to. Knowing something in the cognitive science sense involves having a mental representation of that thing, a concept that generalizes beyond specific instances and that informs behavior across contexts. A dog that whines at the door where its recently deceased owner used to enter is not necessarily demonstrating knowledge of death. It may be demonstrating the absence of an expected sensory input and the behavioral response to that absence. These look similar from outside, but are fundamentally different cognitive events. The concept of death, in the full sense that mature humans grasp it, involves understanding several things simultaneously. That a living thing has become permanently non-living, that the change is irreversible, the dead animal will not return, that the dead individual was a specific, distinct being whose absence is different from a temporary absence, and that death is a universal fate, that it will happen to other individuals, and potentially to oneself. Research in developmental psychology finds that human children develop this full concept of death gradually, typically completing it around age 7 or 8. Before that, children may understand some components, that dead things don't breathe or move, without grasping irreversibility or universality. Whether any non-human animal achieves this full concept is not established. What is established, increasingly clearly, is that many animals demonstrate behavioral responses to the death of conspecifics, members of their own species, and in some cases members of other species with whom they have formed bonds, that are far more complex and far more specific than simple responses to absent companions. Let's talk about elephants in more detail, because the elephant data is the most extensive and the most compelling of any species. Field researchers working with African and Asian elephant populations have documented repeated, consistent patterns of behavior around dead or dying elephants. When a group member is dying, other elephants often remain close, touching and vocalizing. When death occurs, they may stand near the body for extended periods. They show behavior that is different from their behavior toward living group members. The touching is gentler, more exploratory, less social in the normal sense. The bone-touching behavior is particularly striking because it demonstrates something beyond a response to a dying or recently dead individual. Elephants respond to the bones of dead elephants, animals they may never have known, whose bones they are encountering for the first time, with specific investigative behavior that they do not show toward any other kind of material in the environment. This selectivity suggests that elephants have some category representation of elephants as a distinct kind of being that retains significance even after death. They recognize elephant bones as belonging to a category of thing that deserves attention. They cannot be responding to the specific individual. They never knew the individual whose bones they are examining. They are responding to something more general. Whether this constitutes knowledge of death is debated. What is not debated is that it is specific, consistent, and not explicable by simple learning or reward mechanisms. The cases involving known individuals are even more striking. A mother elephant whose calf has died may carry the dead calf, supporting its body and preventing it from sinking in the case of calves that die in water or attempting to lift or nudge a dead calf on land for extended periods. This behavior has been documented lasting for days. It is metabolically costly, practically useless if the calf is dead, and explicable only as a response to the loss that goes beyond the immediate practical calculation. The elephant data also includes something that is rarer and more significant still: evidence that elephants show distress specifically when they cannot be with the body of a dead group member. Groups that are moved away from a carcass before they have completed their investigation of it show behavioral agitation that is distinct from ordinary distress. The incomplete engagement with the death event appears to matter. This is consistent with something that has the character of a mourning process, a specific behavioral and emotional response that has its own time course and that is disrupted by interference. Now let's talk about cetaceans, whales, and dolphins, because the dolphin and whale data on death-related behavior has expanded dramatically in recent decades, and it reveals a picture that is at least as complex as the elephant data. The most documented cetacean death behavior involves what researchers call epimelectic behavior, carrying behavior, specifically the carrying of dead or dying young by their mothers. Bottlenose dolphin mothers have been documented carrying dead calves for periods of days to weeks, supporting the bodies at the surface, attempting to nurse them, and showing altered social behavior compared to their normal patterns. This behavior has been documented in at least 15 cetacean species. In most cases, it involves mothers and dead calves, but it has also been documented in other group members and in some cases in animals carrying the bodies of individuals from different species. The behavior is not explicable as confusion about the calf's condition in most documented cases. The calves show clear signs of death visible even at a distance, and the mother's continued carrying persists for days after any reasonable expectation of recovery. Orca pods, highly socially complex with long-term family bonds maintained throughout lifetimes that can exceed 60 years, have been documented showing altered behavior after the death of group members. They may vocalize more, change travel patterns, spend time in locations associated with the dead individual. In 2018, an orca designated Tahlequah carried her dead calf for 17 days and over 1,000 miles of travel in the Pacific Northwest. The event attracted global media attention, partly because the behavioral pattern was so recognizable. The word grief was used in coverage almost unavoidably, despite the scientific caution around applying human emotional categories to animal behavior. Now let's talk about domestic animals, because the evidence from dogs and cats, animals with the longest history of close relationship with humans, provides a different and in some ways more immediately accessible window into animal responses to death. Dogs show behavioral responses to the death of human companions that are consistent across documented cases. Reduced appetite, increased vocalization, searching behavior in locations associated with the deceased person, and periods of reduced activity are among the most consistently reported changes. These behavioral changes are not explicable as simple disruption of routine because they are specific to the loss of the person rather than general responses to environmental change. The most famous historical case is that of Greyfriars Bobby, a Skye Terrier in 19th century Edinburgh who reportedly spent 14 years at the grave of his owner following the owner's death. Modern documentation is more rigorous. Studies of bereaved dog owners consistently find that their surviving dogs show behavioral changes that parallel the human grief response in observable terms. Changes that begin at the time of death and persist for weeks to months before gradually resolving. Cats show analogous but less extensively documented responses. The behavioral pattern in cats tends toward withdrawal, reduced social engagement, and altered activity in locations associated with the deceased. The literature on cat grief is smaller than the dog literature, partly because cat behavior in general is less well studied, and partly because the expressions of distress in cats are more subtle and easier to overlook. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Now let's talk about primates, because the primate data on death-related behavior is the most varied and in some ways the most revealing, partly because of the cognitive similarity between great apes and humans and the easier inference of mental states that similarity enables. Chimpanzee mothers have been documented carrying dead infants for extended periods, weeks in some documented cases. The carrying behavior persists even as the infant's body begins to decompose. Chimpanzee communities have been observed becoming unusually quiet after the death of a group member, with reduced social activity and altered movement patterns. Group members may inspect the body of a dead individual, touch it, groom it, and show visible agitation in its presence. In 2009, researchers at the Zambian Sonso chimpanzee community documented a female named Noel, whose infant, Thomas, died at approximately 2.5 years of age. Noel carried Thomas's body for 27 days, occasionally allowing other female group members to inspect and touch it. The behavior across the group showed clear evidence of altered social dynamics. Interactions that would normally have occurred involving Thomas, who had been a social actor in the group, simply didn't occur. The group appeared, in behavioral terms, to be registering an absence. Gorilla groups have shown similar patterns. Dominant females in gorilla groups have been documented remaining with dead infants, allowing other group members to inspect the bodies and showing the kind of extended behavioral change that, in any human context, would be described as mourning. Now let's talk about a category of death-related animal behavior that is less dramatic than a mother carrying a dead infant, but arguably more revealing about the depth of animal social cognition: the response of animals to the death of individuals with whom they had complex, long-term social relationships but who were not close kin. In elephant populations, detailed long-term field studies have documented behavioral changes in adult females following the death of their closest social associates. The specific bonds that field researchers call best friends in elephant society, the individuals whose proximity is sought, whose absence is noticed, and whose interactions form the core of an individual elephant's social life. When these associates die, the surviving elephant shows behavioral changes that parallel the changes seen when calves die: altered movement, reduced social engagement, changes in foraging behavior. But that cannot be attributed to the maternal bond that drives calf-carrying behavior. This matters because it separates the death response from the maternal bonding system. If an elephant's response to the death of another elephant were purely a function of the maternal bond failing to disengage appropriately, you would expect death responses only in maternal contexts. The evidence of responses to the deaths of adult social partners outside the maternal relationship suggests something broader: that the social bonds themselves, not just the maternal subtype, generate behavioral responses to loss that persist after the bonded individual's death. Similar patterns appear in primates. Long-term studies of baboon populations, most extensively by researchers Barbara Smuts and Dorothy Cheney, have documented behavioral and physiological changes in female baboons following the deaths of close social partners who were not kin. These changes include elevated stress hormone levels, measurable cortisol increases that persist for weeks after the partner's death, and increased social contact-seeking behavior, as the bereaved individual appears to attempt to compensate for the lost relationship through investment in other social bonds. The cortisol data is particularly significant because it provides a physiological correlate of the behavioral changes. The animals are not just behaving differently. Their stress hormone systems are responding to the loss in ways that are measurable, specific, and temporally consistent with what would be described in a human context as grief. Crow and raven behavior around death deserves specific examination because it is both well-documented and deeply counterintuitive. The idea that corvids, birds with brains organized very differently from mammalian brains, might show death-related behavior challenges, assumptions about the cognitive requirements for such behavior. Field researchers and crow behaviorists, most notably the research group at the University of Washington led by John Marsluff, have documented what they call crow funerals, gatherings of crows around a dead crow in which living crows land near or on the body, vocalize in specific patterns different from their ordinary repertoire, and in many cases mob the area in large numbers. This gathering behavior has been reproduced in controlled experimental conditions using taxidermied crow bodies, and the results showed that crows not only gathered around the dead crows, but subsequently showed increased wariness around the humans who were present at the time of the encounter, suggesting they were forming associations between the human and the death event. The crow funeral behavior may serve a functional purpose, sharing information about a threat that killed the crow, identifying dangerous locations or individuals, which would explain its existence without requiring us to conclude that crows have a concept of death similar to the human concept, but the behavior is specific to crow bodies. Crows don't gather around dead squirrels or dead pigeons in the same way. The specificity is consistent with something that recognizes the crow body as belonging to a category that warrants a specific social response. Now let's talk about the evolutionary dimension, because the question of why death-related behavior exists at all, if it doesn't serve an obvious, immediate practical function, is one of the most important questions in this field, and one that has several credible answers. The simplest explanation is that death-related behavior in social animals is a byproduct of the social bonding systems that evolved for very good reasons. Animals that live in stable social groups with long-term bonds have fitness advantages. They cooperate better, protect each other more effectively, share information more reliably. These bonds are maintained by positive social behaviors and by the specific recognition of individual group members as distinct, valued social partners. When a bonded individual dies, the systems that maintained the bond don't switch off instantaneously. The expectation of the individual's presence, the behaviors directed toward that individual, and the emotional state associated with the bond persist for some time after the individual's death. The behaviors that result, the carrying, the returning to the body, the altered social activity, may not be adaptive in themselves. They may be the non-adaptive byproduct of adaptive bonding systems encountering a situation those systems weren't designed for. This explanation is compelling for the initial behavioral response to death. It doesn't fully explain the bone-touching behavior in elephants, where the individual in question may have been unknown to the elephants investigating the remains. For that, something additional is required. Some kind of category recognition of elephant bones as a special kind of object, which implies a more abstract representation than simple bond persistence. Now let's talk about what this research means for the broader question of animal consciousness and animal emotional experience, because the implications extend well beyond the specific topic of death. The scientific study of animal behavior has been cautious, for good reasons, about attributing human emotional experiences to animals. The error of anthropomorphism, projecting human mental states onto animals whose cognitive systems are organized very differently, has produced misleading claims and bad science. The corrective has been skepticism about emotional attribution, and that skepticism has served science well. But the corrective has sometimes swung too far in the direction of denying that animals have anything resembling emotional experience, partly because emotional experience in animals is methodologically difficult to study, and partly because the denial of animal inner life was convenient for the many human activities that depended on treating animals as though their experience of the world didn't matter. The death-related behavior data provides one of the strongest arguments for a middle path, taking animal behavior seriously as evidence of internal states without projecting the specific content of human emotional experience onto it. When an elephant carries a dead calf for days, spending metabolic energy and social attention on an animal that can provide no reciprocal benefit, the most parsimonious explanation for that behavior involves something like distress, something like attachment, something like a state that persists in the absence of its trigger. The language we use for those states in humans is grief. The caution appropriate to comparative psychology suggests we don't assume the states are identical. The evidence suggests we don't assume they are absent. Now let's address what is probably the most philosophically significant question in this territory: whether any animal has a concept of its own mortality, an understanding that it will one day die. This is different from responding to the deaths of others. It requires a level of self-awareness and temporal reasoning, the ability to project oneself into a future state, that is cognitively demanding in ways that death-related social behavior is not. The mirror test, developed by Gordon Gallup Jr., has been used as a measure of self-recognition in animals, with the inference that self-recognition is necessary but not sufficient for self-awareness. Great apes pass the mirror test reliably. Dolphins, elephants, and some corvids have shown evidence of passing. Many animals do not, but passing the mirror test doesn't establish the kind of temporal self-projection required to understand one's own mortality. Research on this specific question, whether animals anticipate their own death, is substantially less developed than research on responses to others' deaths, partly because it is much harder to design experiments that could answer the question. What is clear is that some animals in the period before natural death show behavioral changes that are consistent with awareness of incapacity. Reduced movement, withdrawal from social activity, behavioral changes that parallel the end of life behavioral patterns documented in humans. Whether these changes reflect awareness of death specifically or simply awareness of physical decline is impossible to determine from behavior alone. And this is ultimately what the research on animal death awareness reveals about the nature of the question. The animals are telling us something. The elephants touching the bones, the dolphin mother carrying her dead calf across miles of ocean, the crows gathering in silence around one of their own, the chimpanzee community going quiet, the dog that won't leave the grave, the female baboon whose cortisol spikes after losing her closest companion. They are showing us behaviors that, in any human, we would recognize immediately and call by a specific name. Whether the internal experience behind those behaviors matches what a human feels when they grieve is a question that may never be fully answerable, because we have no direct access to any mind other than our own. And the methodological gap between behavior and experience is one that science has not closed and may never close entirely. But the behaviors are real. They are documented, replicated, consistent, and specific in ways that cannot be dismissed as simple reflexes or confused responses. They are the evidence that the experience of losing a member of your group, the specific disruption of bonds that were ongoing, the specific absence of a being who was present, is not exclusively a human experience. Death may be universal. The response to it, in animals with the cognitive complexity to form lasting bonds, may be universal too. We just spent a very long time assuming it wasn't.